Hello and welcome to another Ramble with me. Today we are looking at the department's May 2022 paper 2 and we're looking at question 4. It says, in the diagram, the circle centered at MAB, so we don't know what the center, what the coordinates are, is drawn. T and R60 are the x-intercepts of the circle. A tangent is drawn to the circle at K57. Okay, so there we go. Right, so the first question says M is a point on the line y is equal to x plus 1. Okay, so if we were to draw this line, we'll just sketch it for ourselves. Y is equal to x plus 1 is the y is equal to x line, maybe something like this. And it's been moved up 1 unit, so it would maybe look something like that. I don't know. Okay, this is just for me to get a rough idea of what it looks like. Okay, right. So this is y is equal to x plus 1. Okay, cool. So the first part of the question says write B in terms of A. Okay, so because we know that AB lies on the line, even though I didn't quite draw my line through M, what that means is that when x is equal to A, y is equal to B. So we just slot it into the equation of the line. So when x is equal to A, y is equal to B. Right, and that's as simple as that. That means B is the same as A plus 1. Okay, and then calculate the coordinates of M. Oh. Just like that. Just like that. Okay, so what can we do? We know 2 of the points on the circle, and we know that the radius of a circle is constant. So the distance from here to here is the same as the distance from here to here. So let's just formulate that for ourselves. So R, the radius of the circle, is the length of MK is also the length of MR. So let's start with the length of MK. So that is the difference between the y's and the difference between the x's. Okay, and then MR would be, again, the difference between the y's. I'm going to say b minus 0 squared, and then the difference between the x's. Okay, so essentially our equation is that 7 minus b squared plus 5 minus a squared is equal to b minus 0 squared plus a minus 6 squared. So we have an equation, but we have 2 unknowns, and I guess this is where this clue is important, because that becomes our second piece of information to help us find these 2 unknowns. So we can replace b with a plus 1, because we know that that is the relationship between a and b. So let's just quickly add another page for our workings. Okay, so let's just do the replacement then. So we have 7 minus a plus 1 squared plus 5 minus a squared is equal to a plus 1 minus 0 is just 0 squared plus a minus 6 squared. Okay, and if these square roots are have the same value, then that means that what is being square rooted also has the same value. You can also think of it as, we're squaring both sides. So we can drop our square roots So we have 7 minus, and I'm just going to multiply this out, a squared plus 2a plus 1. Oh, ish, I'm squaring the wrong thing. Oops. Sorry. Okay, so what I need to do is 7 minus a minus 1. We're squaring all of that. This I can multiply out. So this will be 5 times 5 minus 5a minus 5a, and then minus a times minus a is a squared. And then on this side, we multiply out a plus 1 times a plus 1, so that will be a squared plus a, so that's 2a plus 1. And then this second product becomes a squared minus 6a minus 6a. Shrinky, shrinky. And then the last term is 36. Okay, almost there. So 7 minus 1 is 6, and then minus a squared, and then there's nothing left to simplify here. On this side we have a squared. Oops, let's make it a bit thicker. We have a squared plus a squared, which is 2a squared. We have 2a minus 12a, so that will be minus 10a. And then lastly we have 1 plus 36, so that would be then 37. Right, and then here we can multiply out our product here. 6 times 6 is 36, minus 6a minus 6a minus a times minus a. Right, okay, so look for like terms again. So we've got 36 and 25. We have minus 12a minus 10a, and lastly we have a squared plus a squared as well. So that is 2a squared minus 12a minus 10a, and then 36 plus 25 is 61. Okay, so now we have 2a squared to 2a squared on both sides, so we can take both of them off the scale and it won't affect the equation, right? And then I'm going to get my a's on one side, so minus 22a I'll keep here, and then the other one will become a plus 10a, and then here we have 37 minus 61, so that is minus 12a, and here we have minus, looks like a 24, right? And so a would be minus 24 over minus 12, which is equal to 2, right? And then we know that b is the same as a plus 1, right? That's what we established in 4.1.1. So since b is the same as a plus 1, okay, let's write that plus properly. That will be the same as 2 plus 1, which is 3. And so the coordinates of m are 2, 3. So let's fill that in over here. Oops, wrong thing. Awesome. Okay. Next question. If the coordinates of m are 2 and 3, thank you, calculate the length of the radius of the circle. So obviously we can either calculate the length of mk or the length of mr. We should get the same answer with either. So I'm going to go with mr. R is equal to mr, which is the difference between the x's squared plus the difference between the y's squared. So that is minus 4 squared, which is 16, and 3 squared, which is 9, square root of 25, which is 5. So the radius of the circle is 5 units long. Right, and then for the second question, we're asked to work out the distance TR. Okay, remember T is an x-intercept, the other x-intercept of the circle. X-intercept occurs when y is equal to 0. So, okay, so we need the equation of the circle, right? And we know that the equation of the circle is given by x minus the x-coordinate of the center, which we now know is 2, and y minus the y-coordinate of the center, which is 3, and the radius of the circle, which they have helped us to work out, is 5, and we square that, so we get 25. So to find the x-intercepts, we're going to try and figure out, okay, what is the value of x when y is equal to 0? So that'll be x minus 2 squared plus 0 minus 3 squared is 25. So we have x. I'm not going to multiply it out just yet, because you know me, I like to conserve my energy. If I can avoid simplifying a product, I will avoid it for as long as I can. Okay, right, so now you can either see by inspection that this thing must be 16, right? 16 plus 9 gives you 25, so this thing must be 16, or you can just think of it as, okay, minusing 9 on both sides. So we have x minus 2 squared is equal to 16, which means that x minus 2 is either equal to positive 4 or x minus 2 is equal to negative 4. So then that means that x is either equal to 6 or x is equal to minus 4 plus 2, which is minus 2. Now, we already know that one of the x-intercepts is r with coordinates 6, 0. So that means that the x-coordinate of t is negative 2. Right, and so therefore, to find the length of TR, so we now know that the coordinates of T are negative 2, 0. Okay. So the length of TR, since this is a nice horizontal line, we don't need to use the distance formula. We can just see that, okay, to go from T to the origin is 2 units, and from the origin to R is another 6 units. So in total, the distance TR is equal to 8 units. And I guess for the radius as well, we can say, well, this is 5 units. Okay, and I am just going to note the length of the radius for myself in case we need it for a future question. Awesome. So, on to the next question. Okay, so the next question says, determine the equation of the tangent to the circle at K. So this guy that we were given here, Write your answer in the form y is equal to mx plus c. Okay, so we are able to find the gradient of the tangent using the fact that the angle between the tangent and the radius is a 90. So we can use the relationship of perpendicular lines to figure out the gradient of this perpendicular line. And then from there we know that the point K lies on the tangent, so we can sub that in to figure out the y-intercept of the line. Okay, so let's do that. Okay, so the gradient of mk is equal to, this is just gradient formula, right? So that is 4 over 3, and so therefore, oops, okay, don't draw on the picture, right on the picture, the gradient of the tangent passing through k is going to be the negated reciprocal of that, right? And so the equation of the tangent is going to be something like y is equal to minus 3 over 4x plus c, right? And then we can sub in k to figure out the c. So we know that when x is equal to 5, the y coordinate is 7. Okay, so that becomes minus 15 over 4 plus c, that 4 is giving me heebie-jeebies. Okay, and 7 is the same as 28 over 4. So therefore c is equal to 28 over 4 plus 15 over 4. So that would be 43 over 4. Very weird looking numbers. Getting uneasy, but okay, maybe it's worthwhile to just double check all my calcs. But yeah, my answer for now is y is equal to minus 3 over 4x plus 43 over 4. Okay, so let's just double check now. So we started by, oh, and also let's just give a reason here. So we know that the tangent's gradient is minus 3 over 4 because mk is perpendicular to the tangent, and maybe let's make it even more explicit. Even more specifically, what we are referencing is the radius mk is perpendicular to the tangent passing through k. Okay, so let's see. We said the gradient of mk, so we did the difference between the y coordinates divided by the difference between the x coordinates. So 7 minus 3, which is 4, over 5 minus 2, which is 3. So then the tangent's gradient will be negative inverse of that, 3 over 4. So then the equation of the tangent will be y is equal to minus 3 over 4x plus c. And then we know that the point k lies on the tangent, so we sub it in. So we have minus 3 over 4 times 5 plus c will give me 7. So we have minus 15 over 4 plus c is equal to 28 over 4. And then the c will be 28 over 4 plus 15 over 4, which would be 43 over 4. So, yep, that seems to be it. On we go. Okay, right. Next question says, a horizontal line is drawn as a tangent to the circle M at the point NCD, where D is smaller than 0, so the y coordinate is negative, so we're looking at something somewhere down here, right on the corners of N. Okay, so horizontal line is drawn as a tangent to the circle M, so it would have either been up here or down here, but because we've been told that the y coordinate of this point N, where the tangent touches the circle, we've been told that that y coordinate is not positive, it is in fact negative. So that means our tangent is down here somewhere. Okay, Right. So this here is our point N. Okay. And we are asked to write down the coordinates of N. Okay, so this we can just do by inspection, right? So we know that the tangent is perpendicular to the radius that occurs, that is connecting this point of contact with the center. So we can draw that radius for ourselves. Yeah, my numbers are not numbering here, but anyway. We move, we move, we move. Or maybe let's try this again. Okay. So we know that, okay, this is a 90. And because we know that this is a horizontal line, then that means this is a vertical line, right? Meaning that the coordinates of N, we don't know what the y coordinate is, but we do know that its x coordinate is exactly the same as N. So the x coordinate of N is the same as the x coordinate of M, because Mn, again more specifically, the radius Mn is perpendicular to the tangent at N, right? And we know that, so that means that, Mn is then parallel to the y-axis, because the tangent at N is parallel to the x-axis, right? In other words, because we've been told that this is a horizontal line, then we know that this is a vertical line, meaning that the x coordinates stay the same, the y coordinates are the only thing that change, right? So that means that the x coordinate of N is indeed 2. Okay, and now we need to figure out the y coordinate, and we can do that by subbing in the x coordinate into the equation of the circle, because N lies on the circle. So this means that, I forgot what the equation of the circle is x minus 2 squared plus y minus 3 squared is equal to 25. So we know that the x coordinate is 2. Okay, we're trying to figure out the y. So we're going to get 2 answers, right? Because it could either be N or it could be this point up here that also has an x coordinate of 2. And then we're going to use the fact that, well, and we know that the x coordinate is d. Sorry, just to be, proper. So 2 minus 2 squared is 0. So we're just left with d minus 3 squared is 25. Okay, so that means that d minus 3 is either equal to 5 or d minus 3 is equal to minus 5. So d is either equal to 8 or d is equal to minus 5 plus 3, which is minus 2. And because we know that d is negative, right, that's what we were told in the start, then we know that d is actually equal to negative 2. So the y coordinate here is negative 2. Right, so for completion, the coordinates of N are 2 and negative 2. Right, and then I think we just have one more question. Okay, So the question says, so we're continuing with the same piece of information as the previous part, where we have this tangent drawn at n, and we found the coordinates of n. Determine the equation of the circle centered at n and passing through t. Write your answer in this form. So let's just quickly sketch that for ourselves. So it's centered at n and it passes through t. Yay. I don't know. Oh, why are you drawing a line? A horrible circle. Okay. Centered at n, passing through t. So maybe something like that. That looks convincing enough. Okay, so let's see. We know the center of the circle is n, and we have a point on the circle which is t, so we can work out the radius. Easy peasy. Lemon squeezy. Lemon squeezy. Okay, so center is 2 minus 2, and then the radius is equal to the length nt, which is the difference between the x's squared plus the difference between the y's squared. So this ends up being a minus 2 minus 2, which is minus 4 squared, is 16, and 0 minus minus 2, which is 0 plus 2 squared, is 4. Okay, that was a very eager line. Relax. Okay, so that is the square root of 20 is our radius, and so therefore the equation of our circle is x minus 2 squared plus y minus minus 2, which is plus 2 squared, and then root 20 squared, which is just 20. That would be the equation of the orange circle. Wow, okay. I hope that this went as well as it felt. Let's have a look at the memo. Let's see if our answers are right. Let's see if we have any interesting approaches that have been taken. Okay, so for the first one, we have b is equal to a plus 1. For the second one, we set up our equations using the fact that radii are the same in a circle, they're the same length, and we do arrive at a is equal to 2 and b is equal to 3. Perfect. So the coordinates of m are 2, 3. Then from there we wanted to find the radius of the circle. Yeah, okay, pretty much what we did here. We got 5 units, and then next up, oh, interesting one that they did for this 4.2.2. So we wanted to find the length of TR. They used the fact that, okay, if we draw this line here from the center, passing through this chord over here, okay, we know that line from center of circle perpendicular to chord. So we've constructed it so that it's a perpendicular line, will bisect the chord. And this point over here, we know what this point would have to be in order for this line to be perpendicular to this line. This would have to be a vertical line. It would have to be parallel to the y-axis so that it can be perpendicular to the x-axis. So that would mean that this point over here is a 2 and a 0, right? And so because we know that we have a perpendicular line from the center to the chord, then that would mean that these two little pieces are equal in length. And since this is 4 units, then this would also be 4 units. So it would be 8 units in total. So that was another way that you could approach it without needing to explicitly find the coordinates of t. Right. Next up, what we got? Oh, let me see if they have other interesting things. Yeah, the other approach was to use what we did with finding the coordinates of t using the fact that it's an x-intercept. And then the equation of the tangent, yes, indeed, it is this weird looking equation. Y is equal to minus 3 over 4x plus 43 over 4. Pretty much standard approach to finding the equation of a tangent. And then the next one, they just have n is 2 and minus 2. Oh, we don't need to do all of this working out because we know the length of the radius. Oh my goodness. So because we know, so firstly we know the x-coordinate because this is a vertical line, but then we also know that the radius is 5 units. So from here, 5 units down would be minus 2. Meow, 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 meow. Sometimes marker locations also help you figure these things out. Hey, that should I really be exerting so much effort? But anyway, however many pages it takes to do your workings, do your workings. Don't be ashamed. Okay, right, and then the last question. Yeah, there's nothing standing out for me there. And just like that, 20 marks. A 20-mark question. Was that a 20-mark question? Was that really a 20-mark question? Oh, a 20-mark question. Wowzers with trousers. Okay, I hope you enjoyed going through this question. I hope it was helpful as usual. And yeah, see you another time for another ramble.